So in the lesson you should have collected data. The data should have allowed you to plot a graph like this one, or more exactly like this one. So you'll notice that there's a number of points throughout the graph where you've got a measurement of the CO2 or O2 or whatever it might be, the gas is produced. So here every so many seconds, so it looks like about every 5 seconds here, or every 4 seconds, they've collected data for the volume of O2 in this particular graph that's produced, and they keep sampling it. So rather than, say, taking a final volume of gas produced at 120 seconds, where all those values would be very similar, they sample it at different times, showing that actually this third line here, the green, produces oxygen at a much greater rate than either red or blue, even though they all end up at the same volume produced, because at the end of the day, once you use up all your reactants, the volume of gas produced will be always the same. It's just that some reactions will get there more quickly, will get to the maximum more quickly than others. So remembering that the rate of reaction is equal to the amount of reactant used over time, or the amount of product formed over time. And in our particular case on the graphs here as well, we used the amount of product formed, which is the volume of gas. So you can work out your rate of reaction, which will be your gradient of the line at any point. So you'll just be able to see on this graph, just right down here, that you've got a gradient there, and that would be the amount of product divided by time. So you could work out a gradient of that line at any point. So just zoom in here, get rid of this one, and you can see more clearly that this is how you take the gradient of a line. You can see them on there. So like I said, for your homework you have to compare your method to an example one, and I've got an example of a method which was written out well by someone, and you can see it here, noticing that they include exact measurements for the volume of hydrochloric acid to use, and they name the acid as well, and that you've got the fact that you need to pour into the acid into a chemical flask and leave it a few minutes so the acid reaches the same temperature as the water bath. Marble chips go in, and they've specified the mass that they would use, how long they leave it for, what rate they sample it at, so every 20 seconds they're recording the volume of gas, and what temperatures they would use, and so on. Now this obviously lacks a risk assessment, which is the other part of it, but I went around to most people's books and most people got the risk assessment fine. It was just the actual method that you use must be very specific if you had to do this in the exam.